Hello everyone and welcome to this new episode of Competitive Programming in C++, and in today's class we'll be discussing about basic math which is required for C++ competitive programming. I will not be touching vectors or matrices here. I'll be only be touching the basic math functions, operations, so on and so forth, how to reverse, how to find the number of digits, what's Euclid algorithm, GCD devices, etc. So before we jump forward, you need to know what is an operator. An operator is something which gets operations performed on. Op operand is something which performs the operation. If I were to tell you there's a mathematical expression, let us take 29 plus 30. What are the basic mathematical operations? Like the basic mathematical operations that we deal with are you have addition, you have subtraction, you have multiplication, you have division, right? These are the operations. These are the operations that you perform uh, in C++. Mathematical operations which you can perform. These are also called as the arithmetic operators as well. No issues about that, right? So operator is something which gets operation performed on. So in this case, as you can see here, my 29 is an operator and my 30 is also an operator because these both get operations performed on. Okay, and the symbol plus or minus or multiplication or division, these are my operands in the statement, whichever the statement which I previously mentioned. Okay, modulo is a very important operator. As I said before, operand is something which gets performed operations on itself, and operator is used to perform the operations. Okay, modulo is a very important operator because it gives me the reminder. Now, what's the importance of getting the reminder? Let me tell you. I have like a simple division 29 by 2. Okay. I want to know what is the reminder of this. If I go 24 by 2, 2 ones are, 2 ones are, 2 twos are, the reminder is 0. If I say 29 by 2, what's the reminder? You need to go 2 ones are, you can go 12s are, and then 14s are, and the reminder will be 1. But if I were to tell you a very big number, for instance 229729 divided by 17, well, that becomes a messy task again. So that's why we use the modulo operator. If you perform the modulo operator 22279729 modulo of 17, you will actually get the reminder in C++. I'll show you by an example. Uh, yes, please. Int A, I'll take this A, and then see out A modulo 17. So let's take A modulo 17. Okay. If I take A to be something like a very big number, I'm giving the input here. So notice, observe here. Let us take something a very big number. It's actually massive, right? If I were to tell you what is 1313123 divided by 17, what's the reminder? If I want to check if it's divisible or not, because if 1313123 is divisible by 17, then my reminder should be 0, right? If I were to tell you 17 is a divisor of this massive number, then the reminder should be 0. That's where I can use the modulo operator. Now to check this, I use the modulo operator. Here I press Ctrl Shift R. Take some time to compile. The reminder is 9. It is not divisible. If I take something like 2, 2, is it divisible? No, it's not divisible again. If I take like 1313, 13113, again I'm getting reminder 6, 13114, 7, 13111, 4, 13110, 3, 13109, 2, 13108, run it, 1, 13107. Now this number massive number. You can't actually tell if 13109 is actually divisible by 7 or not. I can check it via modulo operator and I can tell that it is divisible by 9 because it gives me the remainder. Wait, it gives me the remainder 2 107, sorry, 107, 13107. It gives me the reminder 2, sorry, 0. And now I can successfully conclude that 13107 is has a divisor and 17 is one of the divisors of 17 is one of the divisors of 13107. So that's the use of this modulo operator. It's very, very important, alright. That just remember that, and it's used to find the remainder. Forget that jargon. Conditional statements. There's a very easy way to know to know the usage of conditional statements. I have this snippet. Okay, so use for loop when you know the given condition is true and you want to repeat it. What do I mean by this is, for example, you have a for loop, and the for loop, the condition whatever you're putting inside this loop, they should always hold true. Otherwise it exits the loop. Okay, it exits the loop. I'll demonstrate it to you with an example. Okay, for loop, use it when you know amount of times you want to repeat something. While loop, you use it when you don't know the amount of times you'll repeat something. And if loop is used when you don't know whether the given condition is true or not. Okay, so this comes via practice. You need to practice a lot and you'll get used to it. Don't worry, it's not that difficult. Conditional statements are not that difficult, and I'm pretty sure you are accustomed with those in C. It is the same in C. There is no change here. Okay, if you were something else like Python, you would find a change, but there's absolutely no change here. So don't focus a lot on that. And if you don't know how do you use loops in C, I highly recommend to watch a tutorial. Or if you want that, I'll make a video on that as well. Please let me know in the comment section. Okay. The very important thing, digit concept. I have a number. Its value is 1317293. How do I count the number of digits in this number? If I tell you there's a very random number x, let us take x. There's a number. I have a number. How do I count the amount of digits in x? How do I count it? You know what I do? I have to count the number of digits in x, right? I take a variable which has count. I'll divide it by 10. I'll divide this by 10. I'll see how many times it divides before I get reminder which is greater than 0. Why do I need reminder here to be greater than 0 is because I don't count after decimal, right? If I tell you 0.02937, this is actually greater than 0, but if you round it off, it's actually 0. That's why I'll be making an assumption that 0.029 is approximately equal to 0. That's what I mean here. And 0 holds no value. That's why I don't count. For example, I count 0010. It's 2. There are only 2 digits, right? No matter how many zeros you put in front, it's always 2. So what I do here, I take a variable as count. I initialize it to 0. And then I run a loop. Since I don't know amount of times this number x, the amount of digits that this x has, I don't know that. So I'll be running a loop while this x should always be greater than or equal to 0. I'll run a loop x equal to x by 10 and I'll close the loop. And after closing my loop, I'll just, very important step, I'll increment this count plus 1. I've taught you the difference between a plus plus and plus plus a in the previous videos. You go check that out. You can use this, you use it here as well, but I'll use this because it's a bit simpler to understand. And that's it. This is your program to, check if, sorry, to count the number of digits. I'll code it in front of you. If you haven't understood the logic, feel free to ask me in the comment section, okay? I'll take int a. I'll take Cn of a. While a should always be greater than 0, a equal to a by 10. And I'll take another variable as count equal to 0. Count is equal to count plus 1. Cout count. Okay. Let us take A as like a very random number. Okay. Let us see. Its count is 6. Let us count 1, 2, 3, 4, 5, 6. This has 6 numbers and my count is 6. If I take 1, 1, 1, 1, it has 4 digits. Okay. So it's very simple. You might wonder if there's an easy way. There are two ways to do this. The second way, log base 10 of this x plus 1. This is a very interesting observation. This is a mathematical observation. This gives you the number of digits, okay? So there's two ways of counting the number of digits, and the second way is this. I'll show you here. I don't need another variable count. I'll just take it as dig, okay? Cout dig, int dig equal to log 10 of a plus 1. You might wonder, how am I using this log 10 here? It's actually included in bit/stdc++.h. Don't worry about that. There's millions of things included in this library. You don't have to go to each and everything. You'll get in touch with everything down the track. Okay. Wait, I haven't given any input. 3, 4, 5. Wait, why is it giving me 7? Why is it giving me 7? Log base 10 of 1 in dig. Yeah, there is an error here. Is used to uninitialized. Okay, so cn of a. I forgot that. That's my bad. Yeah, see, you have 5 digits here. 1, 2, 3, 4, 5. You have 5 digits. 6. It's still 5. It's not 6. 4, 5, 6. The 6 digits. And if I go any random number, it has 8 digits. Okay. What is now? I'll ask you an interesting question. Let's go back here. Let's go back to this loop. I'll initialize something like let us take, I'll go to the next line, int b equal to 10. Okay, I'll cout b also here. Cout b. Will it print me the value of b? Will it print me the value of b here? Let us see. No, it's not. It gives me an error that b was not declared in the scope. Scope is something what lies inside the loop. So everything here, I'll highlight this. This is my scope for the while loop. Okay. Scope for while loop. I can use this variable which I've declared inside the while loop only. I cannot use it outside the while loop. That's the actual meaning of it. Now, since I've declared int a in main function, and since this main function consists of the while loop, I can use a anywhere inside this main function. I hope you understood this. Basically, if I declare something inside a loop, I have to declare it outside the loop as well. Otherwise, I can't use it outside. That's what I mean to say. That's what is the definition, simple definition of scope. I hope you're familiar with it. And coming to reversing a number, there's only mnemonic here. The only mnemonic is LF modulo 10, comma, revnum into 10 plus LF. LF is the reminder number which I get. I'll explain you the code later, but just see this here. Int A, int LF, int revnum. This should be 0. Okay. Now I go while A should always be greater than 0. I go LF equal to A by 10. And then revnum is equal to revnum times 10 plus LF. And here is the model operator where I use A equal to A by 10. Cout revnum. 1, 2, 3, 4. It should give me 4, 3, 2, 1. It's giving me a garbage value here. Let me see in Y. Yeah, because I haven't taken in C in A. 4, 3, 2, 1. Yeah. Okay. What basically happens in this code is I have taken a random variable LF. You can take it as B also, no issues. So this B basically finds the reminder. The very first reminder is 1, right? Because if I divide it by 10, when you divide 10324 by 10, you get basically 10 yes. So you get that reminder and you just multiply it 0 since revnum is 0. Revnum equal to revnum into 10. This is 0 plus LF. LF is basically 123.4. Okay, and then this goes back and stores the value again, and this repeats multiple times unless and until I get 0.1234, which is greater than 0, and this loop exits here and comes back here. Hope you understood this, and if you didn't, and if you had any doubts, please let me know in the comment section below. I'll be eager to clarify them. Okay, thank you, bye.